Lesson 34, Unknown Angles, the continuance of the week, May the 3rd through the 7th. So make sure you have Lesson 34 out in front of you. Alright, our goal is to develop an understanding of how to determine a missing angle in a right triangle diagram and apply this to real-world situations. Alright, so let's go ahead and look at our opening exercise. Dan was walking through a forest when he came upon a sizable tree. Dan estimated he was about 40 meters away from the tree when he measured the angle of elevation between the horizontal and the top of the tree to be 35 degrees. If Dan is about 2 meters tall, about how tall is the tree? Alright, so we're going to kind of mark everything that we know. So it says he estimated he was about 40 meters away from the tree. So 40 here. Alright. The angle of elevation, because he's looking up, the angle of elevation between the horizontal and the top of the tree is 35 degrees. Dan is 2 meters tall. So he's 2 meters tall. About how tall is the tree? So we need to know how tall the tree is from here to here. Alright, so we're going to let X represent the vertical distance from Dan's eye level to the top of the tree. And then we're going to look at this. So I've got, I'm trying to find the opposite of my angle. I have the adjacent of my angle. So I'm going to set it up using tangent because I'm using adjacent and opposite. Alright, so the tangent of 35 degrees is equal to opposite, which is x, over adjacent, which is 40. Alright, multiply both sides by 40. Alright, so I get 40 tangent of 35 is equal to x. Alright, when I enter that into the calculator, I get that x is approximately 28. Alright, so if this is approximately 28, then I now need to add 28 plus that 2. So we would say that the height of the tree is approximately, alright, we cannot say exactly, 30 meters tall. Alright, so it's exactly, or approximately 30 meters tall. Alright, let's look at B. Dan was pretty impressed with this tree. Alright, until he turned around and saw a bigger one, also 40 meters away in the other direction. Wow, he said, I bet that tree is at least 50 meters tall. Then he thought a moment, if it is 50 meters tall, I wonder what angle of elevation I would measure from my eye level to the top of the tree. What angle will Dan find if the tree is 50 meters tall? Explain your reasoning. Okay? So, we are trying to, let's think about what we know. Alright? We know that this tree is also 40 meters away. Alright? And it says if it is 50 meters tall, I wonder what angle of elevation I would measure from my eye level to the top of that tree. So we're saying that this is 50 meters. Alright? They want to know, what is this angle? Okay, that's what I'm trying to figure out. Alright, so we're going to let X represent the angle that we are looking for. Alright? So we would normally set this up. I have opposite and adjacent. So we would set this up as a tangent problem. Now, here's the thing though. I need to know what the measure of this is. I know the whole entire tree is 50. Well, I also know that Dan is 2. So 50 minus 2 means that this here would be 48 meters. Alright? So I've got the tangent of x, because I don't know my measure of my angle. The tangent of x is equal to opposite, which is 48, over adjacent, which is 40. Alright? And then I actually can reduce this if I want. The tangent of x is equal to 8 goes into both 48 and 40, so that would be 6/5. Alright? So what I do, alright, let's enter this into the calculator. I'm just going to, I can't do the tangent of anything, so I've got to figure out what 6/5 is. So the tangent of x would be equal to 1 2/10. Alright? So, let's think about this for just a second. It says, what angle will Ann determine if the tree is 50 meters tall, and explain your reasoning. So we get that the tangent of this angle is 1 2/10. Alright? Let's think about what the tangent of our 35-degree angle is. So the tangent of 35 degrees is 0.7. Alright? So we know that it needs to be bigger than 35. Alright? So we can just determine, or we can go, okay, it's bigger than 35. So now we can do the tangent of, let's say, tangent of 50. The tangent of 50 is 1.19. So we would see, and here we're not going to be able to get an exact measure of the angle, but we can see that it needs to be slightly bigger than 50 degrees. Alright? Now, what do we mean by that? Well, let's look at the tangent of 51. I get 1.2349. So it is somewhere between 50 and 51 degrees in order to get the tangent to be 1 2/10. Okay? Alright. Sometimes we are confronted with diagrams that we're curious about the angle measure. Alright? In this case, we were not given the angle measure for that second tree. In the same way that mathematicians have named certain ratios within right triangles, they have also developed terminology for identifying angles in a right triangle, given the ratio of the sides. Alright? Mathematicians also often use the prefix arc, A-R-C, to define these. The prefix arc is used because of how angles are measured, not just as an angle, but also as the length of an arc of the unit circle. Alright? Now, eventually you will learn more about arcs. Alright, so let's just kind talk for a few minutes and do some note taking here. All right, so let's say that I have this right triangle. All right, so this is triangle ABC. And it is a right triangle. All right, so let's write the ratios for the sine, cosine, and tangent of angle C. All right, so we're looking at the sine of C, the cosine of C, and the tangent of C. All right, so if I'm looking at C as my reference angle, sine would be opposite AB over hypotenuse, which is AC. All right, cosine would be adjacent, which is BC, over hypotenuse, which is AC. And then tangent would be opposite, which is AB, over adjacent, which is BC. All right? Now, let's write the ratios for the sine, cosine, and tangent of angle A. So the sine of A, the cosine of A, and the tangent of A. All right, so now we're doing nothing but switching the angle that we're focusing on. So the sine of A opposite BC over hypotenuse, that doesn't change. Cosine of angle A would be AB over AC. And the tangent would be opposite, which is BC, over adjacent, which is AB. Mathematicians have developed some additional terms to describe the angles and side ratios in right triangles. All right, so let's look at some statements and see if we can determine the meaning of each one. All right, so let me write these. Okay. So the arc sine of AB over AC. Okay. The arc cosine of BC over AC. And the arc tangent of AB over BC. Okay? So I want you to kind of make and explain a guess about what these statements mean. All right? So mathematicians use, and let me put this. Mathematicians use arc sine, arc cosine, and arc tangent to refer to the angle measure that results in the given sine, cosine, or tangent ratio. For example, for this triangle, mathematicians would say the arc sine of AB over AC is equal to the measure of angle C. All right? So that means that the angle that has the sine ratio equal to AB over AC is the measure of angle C. All right? Let's look at arc cosine of BC over AC is equal to the measure of angle C. This means that the angle that has a cosine ratio equal to BC over AC is equal to measure of angle C. And same with the arc tangent. The arc tangent means that the angle that has the tangent ratio of AB over BC is the measure of angle C. Now we can use a calculator to help us determine the values of arc sine, arc cosine, and arc tangent. On most calculators, these are represented by buttons that look like this. Alright? And on our calculators, that's what they look like. Now, I'm not 100% sure what it would look like on a phone calculator. So if you had an iPhone, but if you look at our calculators, you will see that we have the arc, sine, arc, cosine, and arc tangent buttons. Alright? Alright. So let's revisit the example from the opening. Alright, let's go back to our opening example. How could we determine the angle of elevation that Dan would measure if he is 40 meters away and a tree is 50 meters tall? Well, we could let x represent our measure, our angle measure, and we would set it up the same way. The tangent of x is equal to 48 over 40. The tangent of x is equal to 6/5. The tangent of x is approximately 1 2/10. So what I would do is I would do the tangent, the arc tangent, I would enter it as the arc tangent of 1.2, and I would figure out that my x needs to be approximately 50.1944, or approximately 50 degrees. Okay? Alright. So let's go ahead and look at some of these examples. Find the measure of angles A through D in the nearest degree. Alright, so let's look at what we have. We have sides of 13, 20, and we want to know what A is. So let's look at the A. We know we have adjacent over hypotenuse. Adjacent over hypotenuse is cosine. So I know I'm going to do the arc cosine of adjacent over hypotenuse. So 13 over 20. Alright. So I'm going to, let me show you how to put this in the calculator. So I go to my sines and I find my arc cosine. Alright, which is here. I enter 13 divided by 20, hit enter, and I see that my angle is approximately, and it says round to the nearest degree, is approximately 49 degrees. Alright, so the measure of angle A should be 49 degrees. Alright, let's look at B. I'm looking at angle B. In here I've got my opposite and I've got the hypotenuse. Opposite over hypotenuse is sine. So I'm going to enter the arc sine of opposite, which is 40, over hypotenuse, which is 42. Alright, I'm going to enter that in the calculator, and I'm just going to hit that arc sine button, and I get that it is approximately 72. So the measure of angle B would be 72 degrees. Alright? Alright, let's look at C. I'm looking at, I have my opposite, and I have my adjacent. So here I'm going to use arc tangent. So the opposite, which is 14, over adjacent, which is 29. I'm going to enter that into the calculator, and I get that it is approximately 26. So the measure of angle C is 26 degrees. Alright? Alright, and then D. So D, they give me everything, so I need to figure out what I'm going to do. Alright, I can actually use sine, cosine, or tangent here. Alright, it does not matter because I have all of the information. It doesn't matter which one you choose. I'm going to use cosine. So we'll do arc cosine of, alright, so here's my angle. Cosine is adjacent, so 51 over hypotenuse, which is 85. Enter that into the calculator, and I get that it is approximately 53. So the measure of angle D is 53 degrees. Hopefully you're not having too much of a difficult time with this. I don't think it's extremely difficult. Alright, shelves are being built in a classroom to hold textbooks and other supplies. The shelves will extend 10 inches from the wall. Support braces will need to be installed to secure the shelves. The braces will be attached to the end of the shelf and secured 6 inches below the shelf on the wall. What angle measure will the brace and the shelf make? Alright, so here we've got the shelf is 10 inches, it's 6 inches down the wall, here's our brace. We want to know what is the angle that is created here. Alright, so let's look at the information that we know. We know opposite, we know the adjacent. That means I'm going to use the arc tangent. The arc tangent is opposite, which is 6, over adjacent, which is 10. Alright. Enter that into the calculator. I get approximately 31. So the angle between the brace and the shelf is 31 degrees. A 16-foot ladder leans against the wall. The foot of the ladder is 7 foot from the wall. Find the vertical distance from the ground to the point where the top of the ladder touches the wall. Okay, so we don't have a diagram. You can create one if you would like. So we have a wall. All right, so we'll let this be our wall. It says the ladder leans against the wall. So here's our ladder. Okay. It says the 16-foot ladder leans against the wall, so 16-foot ladder leaning against our wall. The foot of the ladder is 7 feet from the wall. All right. We create our right angle here. Find the vertical distance from the ground to the point where the top of the ladder touches the wall. So look, I'm not even trying to find an angle. I'm trying to find the distance from the ground to the top of the ladder where it touches the wall. How can I do this? Well, shoot, I can use Pythagorean theorem here. All right? So a squared plus b squared is equal to c squared. So 7 squared plus x squared is equal to 16 squared. All right. So we just have to 49 plus x squared is equal to 256. Subtract our 49. I get x squared is equal to, what, 207. Take the square root of that. And x, so So you're going to realize that 207 is not an exact, it's not a perfect square. So I get that x is approximately 14.3875. So x is approximately 14. Alright? So the top of the ladder is 14 foot above the ground. Alright? So now we know that this is 14. Determine the measure of the angle formed by the ladder and the ground. Alright, so we're trying to find this angle right here. Alright, so let's look at this. Once again, I can use different things. Now, here's the deal. I would be very careful using my 14 because it is an approximation. We might want to go ahead and see if we can use the two sides that we definitely know are the measurements. Alright? So let's look at this. That means I know my adjacent, and I know my hypotenuse. So that means I can use adjacent over hypotenuse. I can use the arc cosine of adjacent, which is 7, over hypotenuse, which is 16. Enter that into the calculator, and I get approximately 64. So the measure, or the angle formed by the ground and the ladder is 64 degrees. Alright? Alright. Let's look. We've got a couple more problems, guys. A group of friends have hiked to the top of the Mile High Mountain. When they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. Sketch a drawing of the situation. Okay. So, let's think about this for just a second. Here's my mountain. Okay? They have hiked to the top of the mountain, and when they look down, so they hiked to the top of the mountain, and when they look down, they can see their campsite. Alright? Now, if you will look at this, it forms a right angle. Okay? And it says they know is approximately 3 miles from the base of the mountain. So we know that this is 3. Alright? Alright. Now, they want to know in B, what is the angle of depression? Which means, so here's their horizontal line of sight. They're at the top of the mountain. Here's their horizontal line of sight. I'm trying to figure out this angle of depression. Okay? We want to figure out this angle of depression. Well, actually, I want to figure out this angle of depression. Sorry, marked the wrong one. Alright, so, we're going to say this is 1. Okay? And it says it's a mile-high mountain. That's where the 1 came from. It's 1 mile. Alright? So, now look at this. My angle, opposite, adjacent, I'm going to use the arc tangent. Opposite is 3, over adjacent is 1. Alright? Put that in the calculator, and I get approximately 72. So the angle of depression is approximately what? Well, if this is 72, then this would be what? I said we were originally looking for this one, but we had to use this one to find our angle of depression. So if this is 72 degrees, well, this makes a right angle, so the angle of depression would be 90 minus 72, so that would be 18 degrees. Alright? Alright, last question, number 5. A roller coaster travels 80 feet of track from the loading zone before reaching its peak. The horizontal distance between the loading zone and the base of the peak is 50 feet. Model the situation using a right triangle. So we're going to go ahead and draw our right triangle. Alright, so it says the roller coaster travels 80 feet of track from loading. So we'll let this be the loading zone. And it travels 80 feet of track before reaching its peak. So here's the peak. Alright. The horizontal distance between the loading zone and the base of the peak is 50 feet. So this is 50 feet. Alright? Alright. So, what is the angle? At what angle is the roller coaster rising according to the model? So, I want to know, what angle is it rising? Well, that's what I have. I have my adjacent, and I have my hypotenuse. Adjacent over hypotenuse is arc cosine. So I'm going to enter adjacent over hypotenuse. So the arc cosine of adjacent over hypotenuse is approximately 51. So the roller coaster is rising at approximately 51 degrees. Alright guys, hopefully it wasn't too difficult. If you have questions, reach out, and have a great weekend.